So for that, I will proceed to my main MISP instance. And we'll have a look at the administration tab. And first, we'll have a look at the organization tab. So what we have in MISP is basically each user belongs to one organization. So you cannot have like some kind of floating users that do not belong to an organization. So any user that you have on the application, even the system account or super admin account, belongs to one organization. So right now on our instance, we can see that we have 11 organizations. We have one organization called another org. We have the circle organization with the logo. We have org 1 up to org 6, an org demo, and an org main. When you log in into this instance with the provided user account, you are part of the org main organization. If we click on it, you can see that we have all of these users up to user 100, I guess, that belong to this organization. Let's go back to the list of organization. So what is an organization? Well, it's first of all, it's a group of users. It regroups users. And it also has some optional fields that can be used to describe an organization. These are not required, but if you are managing a community, it's always good to provide information for this. Something that can be also quite useful that we are extensively using is binding user account to domain name. So in this case, we could do something like this for the circle organization. And that would require any user to have their email address being part of the circle.lu domain name, so that we don't have like foreign user out of our organization.
Maybe something to mention there. Obviously, you can make exceptions. So that means that if an organization does have such limitations imposed on them, you can still ask a site administrator to circumvent them. So they're not completely fixed. There's one more interesting thing here. The fields that Sami has mentioned, such as nationality, sector, and so on, so those meta fields that are describing the organization, they actually have so lately actually used besides just being informational. You can use them as anchor points for creating what we call sharing group blueprints. We're going to see that later on. But suffice to say that you do end up spending some time with managing your organizations on your instance and marking everyone correctly by country and so on. It will make your life a lot easier when creating sharing groups in the future, especially if you're in a large community.
So for example, I'm just filling out few fields so that we have a better description of circle. All right. You can also see some users that belong to the circle organization there. All right, so that is for organization. Now, users. Let's see what we have. So basically, user, as it was mentioned previously, they always belong to one organization. So that's what you are seeing here. Users can have a role. We'll go and see what type of roles are available and what these roles allows you to do. We have, I would say by default, 5 or 6 default roles that goes from site admin to read-only users. And these roles can have multiple permissions. All of them can be fully customized. So if you want to remove permission from these roles, you can do it. So let's see what a user looks like. Let's have a look at mine. So you can see we have the email address. This is the username, but also the email address that is being used when we send notification, password reset emails, and things like that. We have the organization for which my user account is linked with, the different role that I can choose from. In my case, I'm an admin, so a site admin on this instance. We have optional fields that are really advanced that we won't describe for today because it's more advanced than the purpose of this training. And then some other option that users can also self-manage themselves. So if they want to receive email address from contact reporter request, field for admins that allow us to disable an email or a user. By the way, talking about disabling, it's always better to disable a user rather than simply removing it from the application, mostly for logging and audit purposes. Because if you remove these users, it's tougher to see like if they had done things in the past to see what they did basically. So if you keep it in the system but just mark it as disabled, it's let's say best practice to do. And then they can also, as a user, they can also self-manage the type of notification they want to see. So if they want to receive notification each time an event is published, straightforward. And if the instance has been configured to send periodic notification, they can also choose the frequency at which they want to receive these notifications. All right. Now let's have a look at the different roles that we have. And you can see we have a huge table that shows the 6 roles that are created by default on every MISP instances. And for each roles, they have a name, few permissions that we will explain, but also a lot of additional permission that really allows you to fine-tune what these roles are allowed to do. And if we go on the right side, we also have limitation and rate frequencies rules that you can enforce for these roles. So if you have a look at the first one, we have for an organ mean the memory limit, which is set to 2 gigs. This means that when a user under this role tries to perform a request, it will never go above these 2 gigs. Andras more or less agree with that. But as a rule of thumb, I think we can say that.
For the PHP part.
Yeah, for the PHP part, yeah. And the max execution time is also the same. So after 300 seconds, it's gonna stop. We also have the search per 15 minutes. This is not for all endpoint. It's mainly used for research endpoint. Research, we've seen that yesterday. It's the most flexible and powerful endpoint to extract and filter information in MISP. And basically, what you can do by default is always unlimited, but what we are seeing most often is you would create an automation user that have higher memory limits, memory envelope, and higher execution time. But to avoid these users take too much resources, you enforce a number of searches they can do every 15 minutes, something like 5 or 10.
Yeah, we generally, on some of our production instances with large communities, if we see some users misbehaving and basically hogging the resources of the server, then we lower their limits, their caps on memory, max execution time, and so on. Something that Sami mentioned here, again, for automation users, basically, a lot of organizations use MISP kind of for 2 reasons. One, to interact with the world outside of their organization, and the other is to manage their internal security needs through MISP. If you're in that situation where you're doing these 2 different use cases, you really don't want an external user to hold up feeding your SIEM, for example. So it would make sense to have a very lax rule for your own internal rule API user, and for all other API users and normal users have limitations in place. So what we're seeing here is a list of the default roles, but you can always create new ones. So if you want to add a secondary publisher role that has unlimited memory access, for example.
Let's do that.
Yeah, why not?
So you just click on the add role button there or on the left side. Then you give it the name. So let's create an automation user, for example. Then you have to choose one of these permissions. So first one, read only, I think it's pretty self-explanatory. The second one, manage own events, means that these users can only manage the event they create. Second one means that they manage event that they created, but also other colleagues from the same organization created. And the last one is the same, but also offers the ability to publish these events.
It's a very common use case that you separate those two roles out. So you have a separate publisher from the ones creating the data. That way you basically have four eyes principle on all your data before it actually gets published and released to the community.
And then you can choose which other permission you want to give to this automation user. So for example, we could say that we want to give it org admin privileges so that this automation user can create user accounts for its organization. We could also specify that it can also have access to the audit system, that it can create auto API keys, that it can create and tag. So you see, you have really a lot of flexibility. Once you're okay with that, you hit submit. And then it's created in the interface.
Yeah. Keep in mind that currently you did not set memory limit. So in this case, it defaults to whatever is the server default. So if you want to zero it out, you would actually override it if that's what you would want to do. But indeed, it's more just give a higher limit for your internal users.
So for example, we could say this and this.
Indeed.
And we could even enforce a rate limit of, let's say, 5 per 15 minutes.
Keep in mind the rate limit only affects the search endpoint. So that doesn't mean that the user cannot misbehave on your instance. There are plenty of endpoints that can be heavy, but the most common ones that are simply executing because of misconfiguration are hitting the search endpoints. Those are the endpoints that you use to extract data in any of the different formats as well. So if you have any tooling that is fetching data from MISP, if you have, I don't know, an ARC site configured or something that will be pulling data from the search endpoint.
And then how can you use this role? Well, when you create a user, since you created that new role, you can then just assign this new role to a user. So when you create a new user, you can choose it from the list. Or if you want to simply update the role of one user, you simply edit the user and you select the role you just created. Okay. So to continue on this, let's say, organization user topic, I propose that we have a look at sharing groups. So sharing groups are part of the distribution mechanism that we have in MISP. So if you remember when we were creating an event yesterday, you could choose from multiple distributions. So to quickly recap, you had your org only, that only users from your organization could see the event. This community only, that means all users having access to that MISP instance can see that event. Connected communities means the same as the one before, so all users can see it, but the event is allowed to be synchronized one hop away from this MISP instance. So it's gonna enable the event to be propagated to any connected MISP instances, but not further. And all communities remove that restriction, so it lets the event be synchronized as far as it can get, basically. So if you have 10 MISP instances connected in series, then if you choose all communities, all of them will get the event. While if you were to choose connected communities, only the starting point and the next instance will have it. Now, sharing groups, this is a different beast. Sharing groups, it basically allows you to select few organization, also called share distribution list, that can be part of a group. And only these organizations that have been defined in this group will be able to see the event. So let's see how you can build a sharing group and how you can use it. So to view all the sharing groups, you go on Global Action and then List Sharing Groups. And then you will be able to see all the sharing group active on your instance. Let's have a look at, let's say, the first one, see what we have. In this sharing group, which is called sharing group with org name and org main, we can see that it was created by the organization called org name. It has one event. So we have one event that is assigned to that sharing group, as we can see here. And if you go back to the sharing group, you can see that we have two organization part of the sharing group, org name, which is the creator organization, and org main. It really sounds similar, but it's definitely not, which is another organization. So let's see how we can create a sharing group. To create a sharing group, you just click on Add Sharing Group. And then you have to provide information about that sharing group. And the first page is the easiest one. Is basically what is this sharing group called and some description. So the UID, you can leave it empty. It's going to be generated automatically by MISP if you don't provide one. And that's what I recommend you to do. So unless you are creating a sharing group that already exists somewhere and you want to reuse that UID, don't provide a UID. So let's pick a name. Let's call it demo sharing group. Then we have a free text where we can provide to whom this data associated with this sharing group is releasable to. This is not going to do anything. It's not taken into account during the logic or ACL verification by MISP. It's just meant for humans to understand to whom the data associated with that sharing group is releasable to. So we could say that it's releasable to the admin organization, org main, and org1. Then we can give a description if you want to be more exhaustive, or just simply say that it's really to. And the last checkbox just allows you to use that sharing group when you are creating data. So you can even prepare a sharing group and not make it accessible to your user. To do so, you just uncheck it. But since I want to use it, I will just make sure that it's active so that it's selectable. On to the next page, we have this small widget that allows us to pick which organization will be part of that sharing group. So first, you can see that we have local organization and remote organization. And actually, that's something that we forgot to mention when we were reviewing organization. So I think it's a good time now to explain the difference quickly between the two. So if we go back to the organization view, you can see that by default, I'm only seeing the local organizations. I can also filter on the known remote organization, and you can see that we see 4 more organizations. And the last filter, called all organization, basically merges the local organization and the known remote organization. So what's the difference between local and non-remote? Well, MISP being, as I've mentioned yesterday, a peer-to-peer system, you will get data that has been created by other organizations. And some organization might not be part of your MISP instance. For example, in this case, if I have a look at the known remote organization, I have the Cthulhu SPRL.B organization, which definitely has no access to my instance and doesn't, by default also, by consequence, doesn't have any user in this instance. But we know about this organization because we received an event that was created by it. So if I click on the view button of this organization, you can see that it's a remote organization. It's not a local one. And I can see that I have 6 events that were created by this organization. So if I have a look at one of the events, you can see that we have a few file hashes and few file name. And you can see that the creator organization, is this Cthulhu SPRL.b. So if an organization appears in the node remote, it just means that you know that it exists and that it has some data on your instance, but that's it. You cannot create any user for them. While a local organization, it's basically a superset of the node remote. So you can create users for this organization, and they might or might not have data associated to it. Okay, so going back to our sharing group, we can choose from the local organization and the remote organization. So for the local, I will just add org1 and org main. And I could choose from the remote organization, but I'm not going to do it because it's not part of the releasable tool that I've described. Next page is how you define how this sharing group will be synchronized with other MISP instances. You have 2 ways to see it. You have the easy way. You enable the roaming mode and you don't have to think about it. And you have the harder way, where you have to enumerate all the instances that are eligible to receive the event under that sharing group. So if we consider the easiest scenario, and I would say that's the one you will probably most of the time use, is simply to use the roaming mode. So that as long as the owner of the remote MISP instance is part of that sharing group, the information will be synchronized seamlessly. So that's why most people are using this roaming mode. Now, if you don't use it and you want this sharing group to be synchronized and to be shared with other instances, you have to enumerate all of these instances that are allowed to receive it. For example, I could say that MISP1 and MISP2 are allowed to receive it. All right. But I will take the easy way and the most efficient way and just make it roaming mode. And on the next page, you have a small summary that summarizes what you're about to create. So it says that you're about to create that demo sharing group, which is intended to be releasable to this organization. This is basically the text that I've put in this input. And then the local organization having access to that sharing group are these ones. The synchronization explains how it's going to be synchronized. So any interconnected instance linked by an eligible organization. And if this is fine for you, you hit submit. And there you have it. We have our demo sharing group. And now to use it, it's pretty simple. Whenever you are creating an event, you can select sharing group. And then you can select the sharing group we just created. So this works for event, but it also works for attributes. So if you want to just assign one attribute to a specific sharing group, you can do it. One good use case, we could, for example, take one of the events we did yesterday. So let's say, for example, the failed spear phishing incident in Luxembourg. And at some point, we describe the person. There we go. For this one, we could say that this entire object shouldn't be visible to everyone on this instance, but only to the approved organization. And to do that, I can simply edit that object, select the sharing group I just created, save it. And now you can see only the organization under that sharing group can view the information. At least can view this object and its content. Okay, so let's go back to our sharing group. Because I see we have a question.
I can quickly answer that. So what is the extend checkbox for? Basically, if you mark someone as an extender of a sharing group, then they can modify the share. The idea behind this is that if I wanted to share with a broad community consisting of subcommunities, for example, if I wanted to share with law enforcement agencies in the Benelux states, I probably will not have knowledge of who the organizations are that I should be sharing with. But I will have trusted partners in the other Benelux states, for example. I have perhaps someone in Belgium that I would entrust an organization to include everyone that is in the spirit of the sharing group. So basically, you're delegating the responsibilities to some other parties that you also trust. Again, normally organizations that are part of a sharing group can receive data and they can create new data with it. But in this case, it's a little bit more flexibility on including others. Just something for the previous thing that I answered, just a quick follow-up. I have the mic for a moment. So there was a question about the org index, whether you could export all the organizations from the Circle instance. I need to check what our settings is, but basically this depends on a setting. So it's a per server decision. There's a setting called Security Hide Organization Index. So that really depends on what we had configured there. I don't remember what it was, but I'll make sure to check after and sanity check it whether our decision was correct on that.
Another question. If I want the sharing group to be visible on the next hop instance, do I need to create it there as well, or will it be distributed with the data from the source instance? That just depends on the roaming mode that you've selected, basically. So if you select roaming mode and the connection between your MISP instance and the other MISP instance is eligible, that means if the remote MISP instance has its host organization configured and part of the sharing group, it's going to be synchronized. If it's not eligible, then it's not going to be synchronized. So you don't have to create it manually. If it's eligible, it will be done seamlessly. But we'll talk about that more when we'll have the session about synchronization and server setup. And actually, I think that's what we should do right now, because it's a good time to do it. So we'll now see how we can interconnect MISP instances together. And to do that, we'll go on the sync action and have a look at the server. So we'll start with the servers. And once we've explained everything that we think makes sense, we'll have a look at the feeds. You will see that the configuration are mostly similar. Actually, the feeds are even simpler. So let's have a look at this remote server. So right now, you can see that on our training instance, we have 4 other MISP instances connected to this one. We have MISP 1, 2, 3, and 4. And on this index, you can do already some quick troubleshooting. For example, you can test the connectivity between the 2 instances. So we can see that the local version is 2.4.2.10, which is outdated. This is not good. And you can also see the remote version as well. The status says it's okay. Compatibility, it's compatible. And the post test, if it's green, it means all good. If it's red, it means not good.
To expand a little bit on that, if it's red, it's very rare that will give an error. But when it is red, it basically means that you have a very small limit of how much data can be passed in a single connection through your reverse proxy. It's super rare that this happens. But we used it a few times to debug some issues and ended up jumping it down on the reverse proxy being misconfigured. But again, I mean, we've seen it twice so far that thing was flagged as an error. over the past 15 years or so.
So on this interface, you can also see the remote user that is being used on this other MISP instance. So basically, we can see that on MISP1, we have a user called user1 at sync user.main.test. We can see that it has the sync user role. The synchronization flag is enabled, and we have information about two other internal flags saying that it's not enabled for this one. So we also see more information about the different type, or rather mechanism, that can be used for the synchronization. So we have the ability to push events from our training instance to MISP1. So that means we can send event that we have locally to that remote instance. The pull is also enabled. That means we can connect on this instance and download all the events that we have access to on this instance and save them locally. And then we have more granular setting that allows us to push or pull different type of data. For example, the sightings, the clusters. We haven't talked about that much yesterday, but basically you can create your own clusters. Same for analysis data. You can decide to push or pull them.
And the reason why we separate those out, especially with the Galaxy clusters, is very often your actual threat intelligence product, so to say, is going to be sitting in the Galaxy clusters. So if you're doing CTI, you're doing threat actor tracking and so on, then that will be cluster level data, while most of the technical data will end up in the event itself. So this is one possible safeguard that some organizations use to filter out some of the high level, more sensitive data.
And then the other are like how to access that instance. Okay, let's have a look at how the synchronization from this server to MISP1 is configured. So you can see that we have the base URL that is set to training 1. So we could even connect to this one. So now we are looking at the content of MISP1. You can see it's really close to what we have locally. That's because most of the events have been synchronized already. The instance name, this is just a friendly name. This is the one that you will see when you're viewing correlation with other instances on your event view.
Very important to get that right, because there is one more thing where this will show up, and that's the sharing group creation. So if you don't label your instances in a way where all your users will understand what that instance entails, then they will, and then you run the risk of your users basically misconfiguring their sharing groups. So a really nice best practice is basically to just use the URL for the name as well. That will be a pretty safe bet, unless it's obviously an internal synchronization that you have between your instances.
That's a good tip. Now the second part, Andras, since it's very important.
Yeah, this is the place where things can really go wrong. So the ownership that you have to describe there, I know it's confusing when you first look at it. That describes who owns the instance that you're synchronizing with. So that means that if I were to create a sync connection to Sami's instance, it would be Sami that I would be describing here, not myself. The reason why we see local organization there is because it's coming from the organization pool that has local users on your instance in this case. So you can select which pool to choose the organization from, either from the local organizations or the external ones. So the organizations that are known by, due to some data being transferred to your instance that it belongs to that organization. Alternatively, you can also immediately use a shorthand here to enroll a new organization. So if you have their UID, you can also just create a new organization ad hoc. So yeah, that absolutely works too. But generally, please just be careful that you don't set your own organization there. The reason for that is that the moment you will push data out of your MISP instance, MISP will check what it can synchronize to the other side. And if it sees that it's your organization that owns the remote side as well, it assumes that it's an internal synchronization, and it will also push your only data over to the other instance. So just something to keep in mind.
That, and also for correct propagation and sharing group under the roaming mode.
Yeah, indeed.
That's exactly what we described. So for this one, where I've selected the roaming mode, only organization that only sync connection for which the owner is part of that sharing group will receive the sharing group. So yeah, you really have to like configure that properly. And that's also what we mean by what is it? Is tight organizer contained in the sharing group list. So that's what we mean by eligible, basically.
Yeah, there is an alternate way of how to do this. There is a small tool that creates this, the sync user setup for you, but you have to log in with a sync user, not with an admin. So if your partner organization gives you a sync user account on their instance, which you would use to interconnect it to your instance, you can absolutely just go to their instance with that sync user account and let it generate the settings for you, so you don't have to worry about that. Yeah, you're a site admin, you cannot see.
So the link appears because I'm a site admin, so I have all privileges. But then when you try to access this page, it realizes that, okay, site admin account cannot be used to create sync server connection.
Yeah, it's doing that because one of the worst things that can happen is that you create the sync user, the sync connection on a remote instance using an actual admin account, and then that will actually be used by the synchronization mechanism. So that means that whenever the other side pulls data, it would be able to see anything from this instance. So yeah, just make sure that you follow two main rules. One, whenever you're creating a sync user for someone, the org of that sync user needs to be the remote parties organization. And when you're adding a sync server, make sure that the instance ownership again flags the remote owner, not yourself. And if you keep these two rules in mind, it's much more difficult to go wrong.
All right, so we've described how to reach that instance and to whom it belongs to, but we still need to prove that we have access to this one, and this is done through the hotkey field. So yesterday we used the API, and you saw how you can create an API key. So what you basically do in this case is you connect to this training one instance with your sync user account. You generate a notarization key or API key on this MISP one instance. You copy paste it in this field. And once you save, you will be able to do a quick check with the connection test to check that you provided the correct information. All right, next are the different synchronization methods that you can choose. So you can choose to have only push enable, only pull enable. So that can be very handy. For example, you connect to, I would say, our instance for the private sector, for example, MISP, and you only want to download data locally, but you don't want to push anything. That's very easy to do. You just don't check the push. You could also do it the other way around. And then you have additional settings that allows you to define different behavior during synchronization. And I think one of the most important one that are a bit hidden, maybe we should make them bigger, are these push rules and pull rules widgets that we have. These are what we call synchronization filtering rules that allows you to really select what you want to push or select what you want to pull, basically. So for the push, you could select and say that you only want to push information to MISP one that is labeled under TLP clear. You could also say that you only want information that has been created by the circle organization to be pushed to MISP one. You could set it up like this. You have a small text that explains what's what configuration you are using, and you hit submit. What I could do is to create another type of rule, for example, on MISP2. Right now I'm editing the MISP2 connection, and I could say that I want to push everything to MISP2, but events and data basically that are tagged with TLP red. Right, submit. And there we go. So you can see now in the main index, we can see that push is enabled, but under certain condition, as we can see, we have rules. If you click on these rules, you will see the rules that have been saved for that connection. And we have this small widget that allows you to check the different rules. So right now, it's filtered event and event to be synced 0 because these two instances have been fully synced before. So there is no changes, basically. And for this one, it says that there is one event pending synchronization, and none of them were filtered. So it can be quite helpful to quickly test if your synchronization rule are correctly configured. But now you might ask yourself or remember, because yesterday I mentioned what happens if I only want to download data that has been created for the past year, for example. Because if you would connect to our MISP instance, you will see that we have data that's dated back from, I don't know, 2015 or maybe even before, and you might not be interested in that data. So you can see that the pull widget to configure the rules is really similar, but it has one additional component, which is this additional sync parameters based on the event index filter. And it's a good thing that we did the API yesterday because it really looks like an API like body that you would send. So as it says there, you could put something like timestamp. And if I save it like this, whenever we try to pull data from MISP1, it will only fetch content that has been modified like 30 days ago until now.
Yeah, maybe a good moment to stop here for a moment to talk about timestamps, because this can be very confusing when you first set up a sync connection. There are actually multiple different timestamps that we use. There is a timestamp which marks, as Sami mentioned, the last modification of the event. So this can be any modification that changed a single attribute, whatever. But there's a second one called publish timestamp, which basically says when data was last published. Now, keep in mind that publishing happens only on your instance. That means that if I were to publish an event and I create a sync connection to Sami 1 month after the fact, he would receive my data on the first synchronization and it would be published on his instance at that moment. That means the publish timestamp on Sami's instance would be 1 month newer than on my instance. However, the timestamp would be the same because those are material changes to the actual event. So when was the last attribute updated, for example, this carries over from instance to instance. So to recap it very quickly, if you're interested in when data has first popped up in an instance, then you should use publish timestamp. If you're interested in when data was actually last modified, then you should use a timestamp. There is an additional thing, which can be a bit confusing, that's date. Date allows you to filter on an arbitrary date that is set on the event creation form. This is not used that frequently. You can also use the other format too. Yeah, so this is something that is not used that frequently because most of the time it's equivalent to the date when the event is created, but sometimes we're describing events that happened in the past. So even if something is encoded today that describes an incident that happened 4 years ago, for whatever reason we're describing it today, you might not be interested in that. You could also set multiple filters. So you could say publish timestamp and timestamp are both 30 days and date 30 days. That way you would not only limit the data set to anything that has been modified in the past 30 days, but also data that relates to something that happened in the past 30 days. So just something to play with and to keep in mind, and don't be surprised if you set any of those timestamps, especially publish timestamp, and you end up synchronizing a few very old events from the other side, even though you set a short time to live there. So yeah, just so you know. There's another question. So there's a question: what would happen if you were to synchronize without any of the rules that Sami has shown being set? So by default, MISP will assume that everything goes. So unless you put something into the allowed tags or allowed orgs list, it basically doesn't do any filtering by default besides the filtering that is inherent to the distribution system. Mm-hmm. So that means that that in order to push something, data has to be at least connected to communities. So if it has a high enough distribution level for that, or a sharing group that includes your instance, then it will get pushed over to you. But it will not look at any of the tags. It will not care about TLP and so on. You need to manually configure those on the sync connection. Keep in mind that that especially with things such as TLP and so on, deciding where to move data is very difficult because MISP does not have an inherent knowledge about other instances and whether they're part of your community, whether they're part of your constituency, and so on. So these type of labels are best encoded by a human, and they're best used on the destination of the data to extract information from the system rather than for the sharing mechanism itself. But yeah, there is a follow-up question. If nothing is configured in the rules, you still need to have push enabled. Yes, absolutely. Mm-hmm. So if push is not enabled, nothing will push. So by default, we do that very often when we first set up a sync connection to another instance. We don't check any of those functionalities. So no push, no pull, no caching, nothing. And we first preview the data. So maybe that's also a good moment to do that. Basically, there are two ways of using synchronization. One is more of this automated way of I create a rule. These are the things I'm interested in. Get me this data every X hours, basically. Then there is the other way of doing it, which is to simply browse the data of the other instance and to cherry pick what you're interested in manually. So if you see an incident that is relevant to you, then you pull that over. So let's have a look at how that works. So what Sami is doing right now is he is viewing the contents of another server. The way this works is our MISP instance in this case is requesting the index.json endpoint of the event scope from the other instance, and it receives a massive JSON blob with all of the events for the given page that you're looking at here. So we're looking at the first page. So it's 60 events that we're receiving the meta information from. At this point, we can also just tell the other MISP instance to cherry pick individual events and to drag those over to our instance. We can also view each individual event and pivot into them and see the actual attributes, objects, and so on that are contained within the event. Okay. So again, we're still not looking at our own MISP instance. None of this data exists on our instance so far. Or well, in this case, some does because they were synchronized before.
Yes, I think the overlap is almost 100%.
Okay. It's a bad example for that.
But that's because these training instances are all interconnected together. So only the data that has been created during training session and that has been synchronized with all the other MISP instances exist. Like we don't have external sources like feeds and so on.
Another use case for the cherry picking is it has to do with that caching system. So we could tell our MISP instance to go to the other instance, take all the attribute values that are visible to our user, and throw them into a Redis cache locally. What this allows us to do is every time we look at an event, if there is a matching event or matching attribute on the remote instance, it will tell us, okay, this already exists on this other instance. We've already cached this over there. And here's a link how you can pivot over there if you're an administrator or part of the host organization to see the actual event on the other side. And what we very often do, we have some collection MISP instances internally at Circle that collect a lot of junk from different sources. So be it spam emails, be it output of automated processes and so on, that we do not pipe into our operational instances, but rather if we have an incident and we see a correlation to one of those internal instances, then we go over there and grab the data that is relevant and pull it over to our operational instance. So this is a really common workflow for the synchronization without actually having push-or-pull enabled and just manually picking the data that you're interested in.
Just to illustrate an example of what Andras has been describing. So what I did is I configure the MISP1 instance to be cached. So basically, I simply enable the caching on this sync connection. Then I refresh the cache by clicking on this button, so that now I have a cache that is like 1 minute old. And if I go back to this event, for example, you can see that now, in addition to the related event, so the event that exists also on this instance that contain the same attribute, we also have one additional one called related servers that shows correlation that we have with that remote server. And so you can see it also in this column. So for example, this one, I could click on this correlation link. And what this redirect us to is basically MISP1. So we are currently viewing an event hosted on MISP1 that contain that value. So you can see it's there. And if you think that this is something that you would like to have locally, you simply click on fetch this event, and your MISP instance will connect again on MISP1, download that event, and save it locally. That was just an example. I just want to come back to pool once again, because I think it's important to mention what does this input field accept. So basically, what it accepts is any filtering parameters that you can have on this event index. So remember, if you click on the magnifying glass, you have different rules, for example, the publish timestamp. Anything that this one accepts, you can use in this pull rule.
Yeah.
I know you will tell me, but it's not the same. This one, you have a UI. On the other one, you have to create a JSON. Well, I refer you to the OpenAPI specification where we have everything described in an API. So it will be basically, I think it's this one. There you go.
So basically, then this is also a good moment to talk about one of the misconceptions of how the synchronization works. You absolutely can just encode a bunch of different rules here. What happens is that MISP will pre-negotiate the synchronization each time it starts a process. And the way that works is it will request the index of the remote side to see what it needs to push or what it can pull from the other side, depending on whether it's a push or a pull. Now, because of this, and this is where the misconception comes into play, the actual synchronization process that can be super long, especially if you're starting out with a synchronization, you don't set many filters, is going to be something really rapid for follow-up synchronization. So we've seen some organizations that say, oh, our initial sync took us 2 days to get all the data back to 2011 or whenever we started encoding information. And because of that, we only scheduled a synchronization over the weekend so that we don't actually interrupt the way we work. Now, this is something you don't have to do. Even if you run hourly synchronizations, MISP will MISP will only query the event index and nothing else unless there is new data. So actually, ironically, the more frequently you do it, up to a certain point, the more performant it will be.
Yeah, don't do it every second. It's
No,
not.
no, exactly. So, but doing hourly synchronizations is a good idea in general.
All right. I think synchronization has been covered quite extensively. If you have questions about this later on, do not hesitate to ask them in the chat. So next we'll move on to feeds, and you will see that it really looks similar to synchronization of with different MISP instances. So this is the feed index. When you're viewing the feed index, it shows you all the feeds that your MISP knows about, but not the one that are being currently downloaded or cached. For that, you need to select them, enable them, and start the caching process. So right now, if I click on Enable field, you can see that we have only 3. The Circle OSINT feed that we produce, one from Botfrey and one from CertPL, the list of malicious domain in Poland. The first 2 feeds have the MISP feed core format. So that means it's a fully supported format that has all the MISP, let's say, functionalities. The last one is free text. And free text, maybe we can have a look at what it looks like. Actually, that was what I wanted to do. I wanted to explore that URL. And you can see that this is definitely not like a MISP format. It's almost like a CSV, but with 1 column. And so if you want your MISP instance to correctly understand what we are viewing and how to correctly save that information, you have to use the correct format. Right. So let's see what, for example, the Circle OSINT feed looks like when we try to configure it. So we have some settings that we can choose. For example, we can decide to enable that feed, to enable the possibility to cache that feed, to enable the possibility to have lookup visible when you are viewing event. So let's check these ones. You can give it a name. This is by default, it's called Circle OSINT feed, but if you don't like it, you can change it.
Something to quickly mention there, the lookup visible part basically will show to all your users what feed something correlates with. But if you don't set that, it will be hidden from everyone besides the host organization users. The reason for this is that, for example, with an OSINT feed, that is additional value added to the data for all your users. And you want to enable lookup visible in general so that they see that, okay, this thing correlates with, say, a Tor exit node feed, something that we talked about yesterday. On the other hand, if you have a very expensive feed that you paid a load of money for and you are not allowed to share with anyone else, if you have that encoded or cached in your MISP instance, you don't want to share that obviously with others. In that case, you would disable the lookup visible part.
Indeed. Moving on, you have the provider. This is also free text. And then the input source. So we have network. This will be like any feeds that are included by default in MISP will have the network one, because that's what allows you to basically fetch the feed from a web server. But in some cases, especially in air-gap environment, you don't have internet access. And so you can only provide the feed through like file-based system. And so for that, you will use local. And instead of providing an URL, you provide a path where your MISP instance can find this file. And then you have to select the correct format under which the feed is. So we have the choice between MISP feed. So the Circle OSINT feed, the format is the MISP feed. We'll have a look at what it looks like in a few minutes. We have the free text parse feed. So the free text parse feed, basically what it does is it downloads the entire feed, like the TXT file that we saw, and it will simply put it in the free text import tools that will extract all the different IOCs that it can extract and then save them as raw attributes into one event. And then we have the simple CSV parser feed. It's almost the same as the free text parse, but with the CSV, you have the possibility to specify in which column is the attribute value located, what is the delimiter used in that CSV. You can have exclusion regexes and so on. Okay, so if we go back to the MISP feed format, we can have a look at the different options that we have for this one. You can provide basic authorization or custom headers if you need. Sometimes you need to provide authorization headers to access a feed. So this is where you would put it. And then you can choose to override some values for event. For example, you can override the distribution. You can attach by default a tag on the event that will be created when you download this feed. You can also attach a tag collection. We haven't talked about what tag collection are, but to quickly summarize what it is, in MISP you have a way to create collection of multiple tags and clusters, and then in one shot apply all these tags and clusters when you select that tag collection. That is what we have. So if you are on an event and you want to apply TLP-white, TLP-clear, and OSINT, you simply need to apply the OSINT tag collection on your event. I will show you an example. For example, this event, if I want to apply all of these tags, I will, as I would do, go into the Add Tag button, click on Tag Collection, select the tag collection called OSINT, click Submit, and you will see that all 3 tags will be added in one shot. And so that's what this default tag collection does. It allows you to attach all of these tags and cluster in one shot whenever you are pulling event from that feed. And really similar to the synchronization filtering rules, you also have filter rules, but this time for feeds. So you see it's exactly the same interface. It allows you to specify a timestamp or a publish timestamp on the event, different tags that can be allowed or blocked, same for organization. Now these options are not available if you choose another format. For example, the free text part, we have filter rule. I don't know how that would work.
It works by pulling the data in and then running the filters on the data.
But like publish?
No, but I don't think you have that in the options when you look at it.
Mm-hmm. Yeah, this is a bit confusing for me.
Okay. But that's for the this is for the MISP format, right?
No, this is the free text.
Okay, yeah, that's kind of weird.
Yeah. It used to not be shown. I don't know what happened.
Yeah, I think that's a bug. No, I thought you were looking at the MISP format.
No, MISP format it definitely makes sense.
Okay.
Definitely. Okay, if we ignore just this part, we have one very important option that we don't have for the MISP format is the target event ID, and the creator organization. So the reason why we don't have these for the MISP feed is because this data is intrinsically, exists at the event level. Because when you create an event, it has an organization, and your MISP instance will know if it already knows this event or not. If it knows about it, it's going to merge it, if it can merge it. And if it doesn't, then it will just simply create a new event.
There is another reason, and that's basically the ID assignment. So the trickiest thing with those CSV feeds that are single column CSVs is that each of the values basically is just a value without any anything attached to it. We cannot just basically rely on overwriting existing values, because those things might have received other modifications on the instance by, say, an admin user, a host org user, and so on. So basically, we have different strategies on how to reconstitute the information once we pull it in on a daily basis, for example. New event each pull, what it will do is it will basically generate a new event every time you execute the pull. So if you have daily ingestion scripts that we're going to be talking about later on how to actually encode those, it will generate a new event with all the data that exists in the feed. Now be very careful with this, because if you set a 6-hour ingestion period and you pull the data in every 6 hours for a few months and you forget about it, you will end up in the case of some feeds with very highly overcorrelated information. So this will cause performance issues, and this will basically be not useful for you at all.
Fortunately, now with the new correlation system that we have, it's gonna behave way better than it used to.
Yes, but I mean, it's still heavy because I think by default it goes up to 20 correlations per attribute, and 20 correlating attributes in every direction back and forth is still heavy for a large feed. So be very careful with this. Generally, my favorite strategy to use there is called the delta merging into a fixed event. So that's the one. Then what this will do is it will align the state of the of one event with the upstream version of the feed. That means that it will also remove data points that have been rotated out of the feed, and it will include anything that is new and leave everything in place that existed yesterday or the previous poll and exists currently. So this is a really sane way of doing it. However, the reason why we give you this option to select these is there are some edge cases where a new event each pool makes sense. For example, if you have an internal tool that is extracting information from your own network traffic, you want to actually see which days you have seen something. So if you do daily events, you want to actually have those repeating values included each day. This is mostly really for feeds where you don't expect the overlap to be too high, but you expect some values to repeat over time.
I think that's not too bad. So how can you use it? Well, let's as an example, let's configure this one. So I will make the lookup visible, enable the caching, and enable this feed. You hit submit. And then if you want to cache it, well, there is the easy way, but the annoying way is to use the user interface. Simply click on this cache feed button. I just started a job. It's going to take a while because the feed is quite large. And then there is the automated way. And this automated way, you simply put it, for example, in a cron job, and every, I don't know, hour and so on, it's going to update it. We'll see later on how you can configure these automated tasks, so how you can automate synchronization, feed pooling, and so on in the next part. So now the cache should be done. Yeah, it's 27 old. And if we look at an event, I'm sure we can find an event. Yeah, on this one, for example, we can see that we have a hit with our circle OSINT feed. So yeah, if you click on this one, you can see the event that has a correlation with the one we were looking at. So we can explore this event. So right now, it looks like we are exploring an event that is hosted on another MISP instance, but it's not the case. We are currently exploring an event that is hosted on a feed. All right? And so you can see this event. So what does the MISP feed looks like? Let's go back to the feeds. Let's select the URL and let's explore what we have. And this is what a MISP feed looks like. So you see we have a bunch of files. Each file is actually, as you can see, a JSON, and it's an event simply. Let's try to take a really small one. Maybe this one, 12K. So when you explore it, you can see it's really like what you have when you're using the API. It's simply the content of well, the information of the event, where you have all the attributes, objects, and metadata linked to your event. So basically, you have one event per file. And if we scroll all the way down, we have two additional files. The first one called hashes.csv. This is a file that has all the hashes of all the attributes contained in every event. So that way, when we do the caching, it's extremely fast. Instead of downloading the entire feed and processing all the attribute, we simply download this hashes.csv file that we store in the fast lookup key value store. And that's it. We have the cache enabled for that feed. And the next one, the manifest, we can have a look at what it is. It's basically what we would see on an event index if we were to browse another MISP instance. So it only contains information related to this event. So who is the creator of that event? What are the tags associated to that event? And that's basically it, I think. It's mostly meta information that can be used for quick filtering. Right. So what else could we... Do we have question actually in the chat? No,
the last one was a while ago.
Don't. Okay.
So in that case, maybe we should take the break now, and then we move over to administering the instance, deploying, and so on after the break.
Good idea. So in the agenda, it's a 15-minute break. So it's 12. So let's see you all again at 35.
See you at 35.
All right, welcome back this time. So next up in the agenda will be MISP setting and diagnostics.
Yeah, so one of the things we should get out of the way early on is MISP is very customizable, sometimes to its own detriment. So you can configure a lot of settings on how they're supposed to work in MISP. The defaults are fine to use by when you install a new MISP instance. So you don't have to worry about it too much, but just know that you have the option to configure a lot. Let's have a quick look at it. So if some of you could go to the server settings. So in order to see these settings, you have to be an administrator. So just so that you know that on your own instance or whatever instance you have access to, normally you might not have access to this, obviously, unless you're a site admin. What MISP will try to do is it will try to warn you of things that are misconfigured, but sometimes it can be a little bit too eager. So as you see here, this is our own training instance. And here MISP will already complain on the server settings dashboard that we have some incorrect settings. That doesn't mean that it's entirely true. So, but let's have a look at it. So most of the settings that you're going to be configuring when you're setting up your MISP instance at first will be in the MISP tab here. So Sam, if you could.
I was just getting rid of that message.
Okay, I see. Yeah, so the only thing that you really need to worry about when you set up your MISP instance is configuring this part of the settings. This is like the bare minimum that you need to configure, especially the base URL of MISP. Basically, this can be a bit confusing. Make sure that you configure the base URL, and if you have any other way how you want your MISP to be accessed externally, then also the external base URL. The reason for that is we're going to be presenting to your users all the links and redirects using the first of the two links, so the base URL, and we're going to be announcing our MISP instance to the world via sharing groups and so on using the external base URL it is set. So that's it. I'm not going to go through all the settings. Maybe something to mention here is how the setting system is to be understood. So you will see that that each setting has a description. Each of them has a validation script. So if you try to enter a value that is invalid for it, it will barf and say, this is not something you can save because the setting is incorrect. And you will very often see the error messages on the right side whenever, and if a line is highlighted and it's showing you the error message, it means that you need to take some action. In this case, we wanted emailing to be disabled. MISP considers that to be an issue because if a user is requesting a new password, for example, you're going to be sending them a temporary password via email. So this would not work. So it flags it as an error, but in this case we want it. Something that is super confusing at times is that there will be a lot of times when you see a setting that has the same default value that MISP comes with, and it will still complain about the value not being set, such as here. You see, here it says that the default object distribution is inherit from event, which is a very same default to use. But on the right side, it says value not set. The very simple reason for that is MISP basically shows you that this is the value that it will assume because the setting is not set, but you need to confirm it for the error to go away. So you just double click on the setting and confirm it. So let's just confirm inherit from event. And now the error is gone because now the administrator has confirmed. So if you want to get rid of all of those errors, very often it's just a matter of just double clicking and accepting the default value. Okay. Apart from that, there is one thing that is going to be, okay, maybe mention that first. Some of the settings you cannot modify via the UI or the API. So you see, for example, changing the Python binary, and this can obviously lead to vulnerability and to getting remote code execution in the system if you had a malicious administrator or a compromised administrator account. So basically, these things you can only change via the CLI. Mostly it's just settings that modify what binaries to use, where to get information from files that are outside of that can be outside of the MISP web root directory and so on. Okay, so if you go all the way back up, and you will see that there are a bunch of different tabs describing different types of settings.
Yeah, just before
okay.
we go over that, yesterday we had the question, how can we configure the default distribution of an event? So since I just saw it on this page, I can show you the settings. So this is default event distribution. You can see that it's set to this community only. If you want to set it to your organization only, as you mentioned yesterday, that's how you do it. You just simply change it and save it. All right.
Yeah. Going back to the tabs, you see that there are a bunch of different tabs that handle different parts of the settings. So for example, if you wanted to configure a proxy to be used with MISP, then this is where you would do it. Same thing with encryption settings and so on and so forth. There are some specialized tabs though that are in some cases not even settings, but more diagnostics. So especially that diagnostic tab is going to be one that you'll be visiting quite frequently. This one runs a bunch of different tests of against your MISP instance and warns you of things going wrong. Don't be alarmed that it can take a little bit longer to load this page than all the others for a very simple reason. It locally checks your Git repository for your current version, then it checks the Git the upstream GitHub repository and tells you whether your version is outdated or whether you're up to date. So in this case, we see that this instance is outdated by 4 minor versions. Patch version levels. So we could execute an update directly from here if you wanted to. There are a bunch of different things down here. I'm just going to go through some of the highlights that you should be paying attention to. One of the most important things that you will see here is the information about your current configuration for performance, especially when it comes to the amount of resources you've given PHP and the amount of resources you've given MariaDB or MySQL, depending on what you use. So these are the 2 main things to check, especially the default values for both of these 2 things are incredibly low. For the installations of MISP that come from either Docker or from our 2.5 installer, you will have pretty sane defaults to use, but in some cases you might want to go way over those defaults depending on the amount of data and users you have. Especially important, and this is something that we cannot predict in advance of what sort of hardware you want to run MISP on. We see some organizations running MISPs on absolutely tiny machines. We even had some crazy people running it on Raspberry Pis. I don't recommend that you do that unless you have very little data. But either way, depending on how much RAM you have available, especially the SQL tuning can make a huge difference. Generally, what is recommended is to have at least half of your RAM dedicated to the InnoDB buffer pool size. This will be one of the biggest boosts to performance you will get from any of the settings. In PHP as well, if you look at the PHP ini settings, these can also really affect how your system works. There are two that might seem trivial, but are super annoying and hard to pin down what's causing issues in the future. That's the upload max file size and post max size limit. These affect how big of a single event a user can upload in one shot, or that can be synchronized to your instance. And it also affects the size of the attachments that user can include in their events. So here we have it set to 50 megs, but it's absolutely safe to go for something really high. You will have a lot of cases where you have large data amounts being pushed to your instance. For the memory limit and max execution time limits, these are not as important as they might seem because you can also configure them per role, as Sami has shown before. Whilst they have a huge impact on your instance, the default settings are fine to use in general, and then you can relax it for the roles where you want to have more resources available. Something else is that you will be probably looking at here whenever you want to tune the performance of your instance is going to be your database schema. Now, this is, I think, one of the most annoying things for us in terms of reports that we're getting. It's very easy to misinterpret it. So in this case, we don't see anything because we're fully aligned with the upstream instance. But in some cases, you will see that your instance is deviating from the expected schema. And that might mean that nothing is actually wrong with your instance. It might just mean that you're running a different version of MariaDB or MySQL than where the schema was generated. Over time, some of the expressions changed in how MariaDB and MySQL announce the state or the type of a row for a column, for example. One of the typical ones, and we recently had a pretty funny GitHub issue about the topic, was the renaming of UTF-8 bin to UTF-8 MB3. That will be, if you're running an older MySQL version, it will be flagged as an issue with all of your fields. Please ignore that. The one thing that I would really use this tool for, though, is to check whether you are missing some vital indexes. So that can be a really nice way to figure out if something has gone wrong during the updates from older instances, or maybe you have some customizations that destroyed some important indexes. Make sure that to keep an eye on that. But other than that, if you have the same version as the upstream expects, generally you should be fine unless you've tampered with the database yourself. Other than that, we have a bunch of checks for various libraries that we're using. So here we can just sift through them. You will have explanations of what each of those are, so don't worry too much about it. I don't want to spend too much more time on the diagnostics, so let's look at the other important part, and that's the workers. So MISP basically has a system to manage background processing. Now, internally, this is actually two separate systems that you might have running. So, I mean, one of the two that you have running, and they work slightly differently. In the case of newer instances, you're going to be using Supervisor as your background processor handler. In the case of older instances, a library called KCRESC. What you can do here at this point is configure the number of workers that you have running and check on their state, check on how many jobs are in the queue, and so on and so forth. Generally, with Supervisor, you don't have to do much. So once you have pre-configured how many workers you have per queue in a config file, which is pretty sanely configured by default when you install MISP, you don't really have to do anything. However, with KCRESC, workers might die, they might stay offline after restart, and so on. So you have to do a bit more work with worker management. Now, all of these things, settings, the diagnostic page, the workers, and so on, are all accessible via the API. For example, in our case, we use OpenMS. And we have these all configured via our OpenMS, and we can monitor the state of the workers. And if I'm not mistaken, we also have automatic heal scripts in place for restarting workers if they die. We also basically have update scripts that allow us to quickly update all our MISP instances in one shot. So there are a bunch of different aspects that that you can automate from the administrative tasks. Some is currently showing a guide. So we have a colleague that is absolutely magician when it comes to OpenMS. He has configured a crazy amount of things to monitor, and basically, I mean, something goes wrong with any of our MISP instances, we know immediately. Be it performance issues, be it something not working as expected, and so on. So have a look at the guide that he wrote a while back. I don't know if it was updated since then, but already the state that we had it in 5 years ago was really advanced already, and we could monitor a lot of things with that.
I just shared the link in the chat.
Perfect. So let's go back to our first settings. So there are some other things that that are vital to configure here. Plugins basically allow you to configure all those enrichment modules, import and export modules, and so on and so forth. So go through all of these when you're setting up your MISP instance. And if you're doing updates to your MISP modules, check back here, because you might have a lot of disabled modules, because we disable everything by default, that have been added over time that might be interesting for you.
Yeah, so for example, yesterday we saw how to perform DNS resolution or IP geolocation. When you install a MISP instance, by default, all of these modules will be disabled. So if you want to use these services, you have to go on the server settings, in the plugin page, on the enrichment panel, and then start to enable them. For example, you can see the BTC scan check is enabled manually. If you have a look at the DNS one that we used, reverse DNS is enabled. And what was the other one? Was MMDB lookup. And MMDB lookup should be. Oh, wait, doesn't filter it. Yes, that's it. You can see that it's enabled. And what's more, actually, you can also restrict the usage of some of these modules per organization. For example, on this instance, only the circle organization or any user that have sat admin privileges can use this module to perform the geolocation lookup. Why would you use that? Well, for example, if you have various total subscription, you put your API key in the setting of that module. Like I think we can even show an example. Let's see virus total. You can provide the API key, but you can restrict who can actually use that module, so that they don't consume. If you give access to other organization to your instance, they don't consume queries associated to your API key. So that can be enforced. So enrichment module, you have the exact same configuration for the import module and export modules. Action module we can skip, it's not that interesting. And basically for any other plugin that we have interconnected with MISP, you will find their configuration under the plugin interface. So yesterday we mentioned quite a lot Kafka and ZeroMQ. That's where you would find the configuration. So yeah, this is for Kafka and this is not Elastic for ZeroMQ.
Something else that we're going to be asking you to run occasionally when you come to us with performance issues is we have a tool called benchmarking here. This one will start saving a lot of information about the different endpoints that are being queried, about the users that are querying things, and so on. And it can give you a lot of insights about what's going wrong on your instance. It's a bit hard to interpret, so by default, you probably don't want to spend too much time on this. So maybe we can have a quick look at the benchmarking. And the tabs are a little bit awkward. But for example, if I wanted to, in this case, see which of my endpoints is taking up most of my execution time, I could select time in this case, and I could do aggregate information. Aggregated, yes. And here we would see all different endpoints that are being queried by the users and which one is taking up the most time. Average per request is actually more interesting as well, because then you can see which of the queries is being heavy per individual query. So you can basically get a lot of information here, memory use as well, and so on and so forth. And in the upcoming version of MISP, or in the current version, last release version of MISP that was released this morning, you also have access to a slow query log that allows you to search per endpoint what queries are being painful. Something to mention here, if you have an older instance, please make sure that in your database.php file, you do not use the MySQL data source. There are more modern options. Have a look at what the default file contains. Those are always updated with every MISP installation, and just copy over the line from there. That's a safe bet. But this is again for instances that are a few years old at least. Okay. Apart from that, for the settings, one thing that we didn't really talk about is the update process. So we saw that we had that little update button there, but that's only half of the story. So basically, once you update your MISP instance, what it will do actually behind the scenes is it will do a git up the pull and a git submodule update. So basically, you will get the latest versions not only of MISP, but also on disk at least, the latest version of MISP Galaxies, MISP Objects, and so on. So the libraries that MISP uses. However, these are not ingested by MISP at that point. You need to ingest all of those. So you see that second button down at the bottom, it's called load JSON into database. The way the process flow should work is first update your instance, and then you will see if any of the submodules are now outdated compared to what is expected, and then hit load JSON into database to actually load those taxonomies, clusters, and so on into your instance. We've seen that in some cases that the second step is forgotten, and we had users stuck on with super old MITRE ATT&CK versions, threat actor libraries, and so on. So make sure that you update these. Now, this is also one of the places where sometimes things can go wrong. If for whatever reason the update fails, you basically, I'm the update in a sense of the database update that might be running together with the actual git pull. You might have the update process stuck. So this is the place that Sami is showing right now, that you have to visit to release the lock and to find out if what the blocking error was for the update. So if you are absolutely stuck with an update and MISP is complaining about missing fields or whatever, this is the place to check. It probably means that for some reason an update cannot go through. Other than that, something that is also a very common error that we see is folks are clicking update MISP in this interface, and before they have to run an update manually via the CLI, using a user other than the Apache user. In that case, MISP will complain about not being on a branch. And the reason for that is that or not being a Git repository, that's the other one. The reason being that it cannot read the Git subdirectory of your MISP installation. So just be careful with permissions. And if you see an error on status or current branch complaining about not being a MISP repository, then this might be the reason for that.
One of the most common mistakes is to pull with the root user account and forget to change the permission and ownership of these files.
Especially of the Git one, because it's a hidden directory. And when you just do chmod recursively on the MISP directory, it will actually skip the hidden directories. So by default, the .git directory will not get updated, and it cannot check what branch you're on, whether you are up to date, and so on. So just something to keep in mind. So I think that's basically it for the settings themselves. Maybe something that we can move on to from here would be to talk about the cron jobs and the automation scheduling of tasks. So that kind of aligns still with the settings.
Just before, a few words about migration from 2.4 to 2.5, if you want to.
Yeah, that's a good point. So we recently, it was a year ago by now, we released MISP 2.5, which is behaving exactly the same as 2.4, but it's running on a more modern stack. So it's running on PHP 8.3 rather than the old end-of-life PHP 7 versions. So we highly recommend that you move over to that one. It also has much nicer defaults. For example, we dropped using CakeResc, and we use our colleague's implementation of background workers using Supervisor, which is way better than what we had before. So we really recommend you to migrate if you're on 2.4 to 2.5. There are, depending on what version of MISP you're running and what type of MISP you're running, there are different paths to updating. If you're lucky and you're running on an Ubuntu machine, it's as simple as updating your distro and then running an update script. If you're running a Dockerized version of MISP, it's probably as easy as getting a new Docker image, as long as your Docker image is coming from the main repository.
Mm-hmm.
Unless you have something custom, then it's obviously more painful. And if it's none of those, you still have the option of simply just installing a new MISP and migrating your data over. Recently, we did that with some of our instances. It's pretty straightforward. So basically, it's a matter of moving your MISP directories, subdirectories over that contain user files. There is a list listed in a tool called MISP Backup. Everything that thing includes, that's in the tools directory of your MISP installation. And additionally, to dump your database and ingest it in the new MISP instance after installation. So that's the most painful way to do it, but it's still quite straightforward to do. But yeah, this is coming. This is if you're coming from a distro or from an installation type that is not Ubuntu or Docker. Okay, and maybe speaking of that, maybe before we do the cron jobs, maybe we should go for installations while we're talking.
Mm-hmm.
So we could probably do that now. So let's talk a little bit, now that we've mentioned Dockerized installations, the native installations, and so on, a little bit about the deployment itself. So there we go.
These are outdated slides.
It's okay. We're going to just talk about
the most important one.
The important stuff, yes. So basically, the two main ways I'd say of running MISP, actually three. I forgot about one that is super nice. If you're running Red Hat, Andreas from Switch keeps an RPM version of MISP. If you were lucky enough to install with that in the first place, it's also super easy to keep your MISP up to date. So keep forgetting about that. So basically, there are three main ways how we recommend you to deploy MISP. If you're coming from an Ubuntu world, especially, we recommend that you do a native install. Here we list the 2.4 install. This should be updated. So it's basically the exact same thing, but on 2.5 rather than 2.4. So that's simply installing it on an Ubuntu installation. If you're coming from Docker world, MISP Docker has you covered. It's super actively maintained. I mean, if you're used to using Docker, it's super painless to go that route. And if you're using Red Hat, then you have the RPM installation or a native installation as well. But there I would recommend the RPM because it's just simpler to maintain. For Docker, it becomes a little bit tricky. There are a bunch of different Docker installations that you can choose from. I would really recommend the first one, and the URL of that has since changed. So this is now accessible via github.com/Docker MISPs or MISDocker/MISDocker, if I'm not mistaken. Yes, there we go. Yeah, MISP/MISDocker. So this is the most official Docker image that you can use. It's again super actively maintained. If you want to go with Docker, go with this, and it's going to make your life easier. Okay, let's move on to the next page. This is for native installs, and when it comes to what we recommend, I mean, we're generally an Ubuntu shop. So we develop everything on Ubuntu, we test everything on Ubuntu, and our CI target is Ubuntu. So you will have the most success in terms of getting help and getting support from us if you're going with Ubuntu. With other OSs, we're struggling because we have to basically spin up a VM to test what's going wrong. Generally, CentOS is dead. So if we keep getting questions about CentOS installations, it was a nice alternative to Red Hat if you didn't want to basically pay the license. But nowadays it has moved into very different directions, and they stopped maintaining equivalent copies of Red Hat. So basically the two main OSs that we see and that we support is Ubuntu and more modern versions of Red Hat and what's listed here. For the hardware specs, this is something that we get very often as a question. What should you use to run your MISP instance on? What are the requirements in terms of hardware? And the answer, and I'm sorry to disappoint in advance, is that there is no firm answer on that. It really depends on multiple things. Generally, that includes both data and usage patterns that will affect what sort of hardware you need. So what we can do as a best alternative to actually giving you specs is walk you through the pitfalls and what actually affects performance. So as a first step when it comes to hardware, please just make sure that you're running it on SSDs. If you're having performance issues because you're still running MISP on an HDD, well, it's because of the HDD. So let's look at some of the actual things that affect performance. So one of the biggest things that impacts data is actually or impacts performance is actually your data and how it is clustered. So whenever we are starting debugging with someone that comes to us with performance issues, the first thing we try to gauge is what sort of data they have in their instance. And this is not necessarily about the amount of data, because you can have huge amounts of data without any serious performance impact, as long as that data is not highly correlated and as long as the event sizes are kept to an optimal level. What this means is, generally, if you have 100 million attributes, which is a huge number, that can work quite well if you have events of, say, sizes of 500 to 1,000 attributes each, and with not that many correlations. And it can be an absolute pain if a large part of those attributes are in a single event, or if if you have very few attributes per event in general, and you have a lot of events. So these two edge cases are basically going to be posing more performance issues. Generally, the best way to avoid these is because most of the really painful clustering issues that we've seen come from incorrect feed clustering, is to improve your feed ingestion methods. So, for example, what we've seen before with the pull into a fixed event rather than a new event with each pull is one such example. With that said, don't keep growing feed-derived events indefinitely. We had one such event that ended up with something silly, like 2 million attributes or something like that. And that became unusable because we simply cannot load that entire thing into RAM in one shot. So just avoid doing that. If you're ingesting large feeds that are growing over time, make sure that you start a new event every X number of days or whenever a certain threshold of attributes is reached. So besides the clustering of the data, there are some other things that can affect performance. Correlation, again, this is something that was an issue before. It's much less of an issue nowadays, since then we have a completely new correlation engine that has a lot of safeguards in place to not blow up in size. So it's not nearly as important as it was before, but you can still generate quite a bit of noise by ingesting the same data over and over again without maintaining the same UUIDs by using a MISP format feed.
Yeah, now instead of n squared, it's like 20 times n.
Yes, exactly. So there is another thing which might affect performance, and that's over-contextualization. Again, this is something that might seem silly at first, but the number of attributes and especially galaxy clusters you assign to an individual attribute can have an effect. So the way to best counter this is to move all the tags and galaxy clusters that affect all contents of an event to the event level. We've seen some cases, for example, where we had a user that was marking every single attribute with TLP labels, and they ended up with large events with 10,000s of attributes where every single attribute was marked TLP green, for example, in an event. That doesn't make sense. If 99% or 100% of your attributes have the same TLP marking, just put it on the event. MISP will automatically adhere to that when it comes to filtering data and searching for data. And then put the exceptions on the actual attributes. So if you have one or two TLP red attributes in the previous example, just mark those with TLP red and mark the event as TLP clear. We had an example for that yesterday when we were doing our little encoding exercise where we showed what that actually looks like. And Sami is now showing an example with TLP amber and TLP red. Okay. Yeah. That's basically it for this.
Yeah, I think so.
Yeah, next slide. Thank you. So there are some things that logically also affect performance, and that really has to do with how you interact with the system. Number of users, we generally differentiate between MISP instances that are used for internal use cases. So you pull data in from all sorts of communities and sources, and you use that data for your internal working data set to feed your different tools, to support your analysis processes, and so on. If that is the case, then make sure that that you account for differences in use cases so that you assign the right amount of resources to each of the different types of roles. But generally, if you offer services for a large community, expect large community to hammer your instance. So another recommendation that we generally have is don't run a single MISP instance if you want to host a community, but run at least two, one for your internal users and one for the community, and synchronize the two internally. Logging strategy can also have a huge effect on what happens to your MISP, especially when it comes to disk space. MISP can be very active with what it logs, especially if you enable some settings. There is one called paranoid logging that will super aggressively just log anything users do. So we generally only turn this on when we expect some foul play. But other than that, we just use the default logging settings. However, if you want to go for any of those options, make sure that you keep tabs on disk space, especially on the disk or the mount where you have your database running. MariaDB MySQL is really bad at dealing with running out of disk, and it can lead to corruption. So please keep tabs on that. The other thing that can bring MISP to its knees is basically searches. So we have some systems in place that basically try to stop users from executing idiotic queries that will kill your instance. Initially, we didn't have any such checks in place, and we had some users that just said, "Oh, give me all the data in a search query," and convert it to sticks2, which is a quite heavy process in itself. And then obviously our MISP instance basically just went nuts on trying to fulfill the request. So nowadays we don't allow empty queries, and we do have some options that you can configure. Especially recently, we got a new feature that allows us to set the maximum number of returned elements. So if someone would grab the entire attribute table in one shot, that will prevent them from doing that.
Yeah, just so you know, this is disabled by default. So if you migrate to a new version, or if you update to a new version, it won't affect anything. It's an opt-in system that you can choose to restrict the amount of data returned when you do searches.
Yeah, so that's one of the ways. The other way is limiting memory usage. So you can also set aggressive limitations on how much RAM the users can use in terms of PHP memory per process. So just keep these in mind, that heavy searches can be difficult to handle depending on what users search for. Especially, we're very flexible with what sort of searches we allow. You've seen that yesterday during the API session, that pretty much any field can be used as a pivot and as a filter. That means that index use in MISP can be painful because sometimes you might end up with a combination of filters that MariaDB simply will refuse to use any indexes on. We recently had a release that allows you, if you have enough RAM, to reindex the most critical tables. We're going to be releasing the blog post either tonight or tomorrow that describes how to do it. I highly recommend that if you have at least 32 gigs of RAM in your server, to run those upgrades, because it can reduce long queries to milliseconds. Again, at the cost of a bit more memory use for your database.
It's always a trade-off, but this one is very cool.
Yes, I mean, it's for us, it solves a lot of issues. Okay. So there are also some misconceptions when it comes to provisioning and what affects your performance. And there are some things that might seem counterintuitive. They might seem like something heavy-handed that you should not do because they will probably kill your performance, that they actually don't. One such use is the warning lists. Warning lists are super lightweight compared to what they do. We keep all of those cached in Redis, all the different warning list rules. So when we do those comparisons, we do it after the data has already been retrieved from the database, and we basically exclude all the values quickly in memory using the dataset derived from Redis. So it is really fast. Obviously, there are some warning lists that are less performant than others, especially for regular expression-based warning lists. It will have a slightly bigger overhead, but the overhead, even if you enable all the warning lists, is minuscule compared to your database query times. So it will never be the bottleneck. So feel free to enable whatever you think makes sense for your instance. Let's go. Yeah. Again, number of raw attributes per, on the instance in itself is not a good indication of performance. You can have well-clustered, non-correlating data that is absolutely humongous, that will not give you any issues, and you could, in theory, have an instance with a single event having 2 million attributes. In that case, your instance will be completely unusable because you have one large event that cannot load it in one shot into memory. So just keep that in mind. A number of sync connections and recurring syncs. These are something that we get a lot of concerns about. Should I add another sync connection? Should I query my sync connections frequently? Or will that degrade performance? The answer is, surprisingly, there is some overhead, but it's not that much. Because if you do frequent pulls and if you pull from multiple sources and the data is overlapping between the different instances, MISP will not pull in anything new unless there is new data with a frequent pull situation, and it will associate the data with existing data based on UIDs if you're pulling the same data in from multiple sources. So actually, it's much less of an issue than it seems. So feel free to do frequent enough pulls. If you do hourly 6 or every 6 hours a pull, that's perfectly normal and fine to do, and it will not have a large impact. You will just have more frequent tiny synchronizations compared to one-shot large ones. So in the end, it might actually be beneficial. Then the other thing is, you can actually make use of the data that flows into your MISP without almost any overhead in terms of processing power, as long as you rely on one of the automation channels that MISP has. ZeroMQ, Kafka, and Syslog. So and there is also Elasticsearch, and I think one more module that you can use for feeding on the data that flows into your MISP. If you use any of these channels, this is basically broadcast to whatever is subscribing to those feeds. Anyway, so there is no additional processing done. We feed the data raw as it gets executed on the server. So there is very little overhead with adding more and more services to these endpoints. Now, moving over to authentication, and this is again something that is by now super outdated. Basically, MISP by default uses username and password authentication. However, this is definitely not what you will be running most of the time. You will most likely be using either a more advanced scheme or a combination of schemes. In our case, we generally use username password together with OTP. So that's something you can enable, and then you can have your users run Google Authenticator or whatever to authenticate with MISP beyond their username and password. Or alternatively, you can use two completely different methods of authentication. So there are some listed here. As of recently, our colleague Luciano has done a lot of work on OpenID Connect. So if you are running, say, Keycloak, and you want to use that to manage your users in MISP, you can absolutely do that.
I provided a link that's showing some authentication plugin that we have in MISP. And if you choose one of them, for example, the OIDC auth, if you access the folder, you will have a README that provide the documentation and yeah, that explains how to set it up and how to configure it.
Yeah. And if none of these systems fits your use case, there is also a custom auth system where you can basically just tell MISP to monitor a configured header, and you can have the value that should be monitored for each individual user saved in the user profile. So that's a fallback if none of the other options work for whatever you're using.
Yeah. So the email OTP, you just need to enable it if you want to use it.
But don't use it.
Don't use it.
Yes.
But it's super easy to do. But there is a better way. That is not mentioned in the slide. Is the TOTP, HOTP. So you could use application like Google Authenticator to scan the QR code, and then you have these TOTPs, HOTPs token that you provide whenever you log in. This is fairly popular functionality.
That's probably your best option unless you have a tool doing it all together. So for tuning, we mostly went through these already, so I'm not going to go too deeply into that. So let's skip over this one.
That's it.
Oh, that's it. Okay. So in that case, you can move on to next topic.
Yep. Hold on, because I had opened something. Oops. And all right, cannot find it back, but it's okay. Next topic is something that might be interesting for you is the MISP workflow. So we've been talking a bit about automation using the API, using the automation channels like ZeroMQ, Kafka, and so on. But there is also another way to add automation in MISP. It's by using the MISP workflow system that's built into the system. So basically, I'm not going to do a full-blown presentation on how the system works because it's a 4-hour-long workshop. But I will just show you an overview of the things you can do, the things you can configure your MISP to do, and then I will provide links if you want to learn more about that system. So basically, the workflow system in MISP can be accessed if you go in administration and then workflows. And on this page, you will see some entries that we call triggers. So triggers are some kind of event that can happen in MISP for which you can listen and create a workflow that will be executed once this event happened. For example, let's have a look at this event publish. So we have a trigger called event publish the description is this trigger is called just before a MISP event start the publishing process. So if you create a workflow for that event publish trigger, every time an event will be about to be published, this workflow will be run. Okay, so now what can you do with this workflow? Well, you can do a lot of things. You can prevent the event to be published. You can attach tags, you can remove tags, you can send notification to chat application, you can perform enrichment, you can modify the data on the fly. So you can do a lot of things. But before we see how that works, let's have a look at what are the other triggers available. So we can have triggers when attributes have been saved. Can have triggers right before an enrichment is being run. That could be useful, for example, if you have really sensitive information that you don't want to disclose to third parties. So let's imagine you have TLP-read, very sensitive file hash that you don't want to disclose to websites, for example, VirusTotal. You can use the workflow system to look for these TLP-read tags. And if the attributes that is about to be enriched is labeled with that TLP-read tag, you can prevent the enrichment to happen so that you don't disclose that information. We have a lot of trigger about event because MISP, as you have all noticed, is very event-centric in how we structure the information. We also have trigger for event reports, for logs, for posts, for sightings, and for user creations. All right. So let's have a look at, for example, the event publish trigger. So if we double click on this entry, we have this interface that allows us to create the workflow. First thing is that I immediately see we have a red border. We have a warning message there that says the module is disabled. So I'm going to fix it by simply enabling my module. So right now, my trigger is disabled. I'm just going to enable it. Now it's enabled. You can see the red border has disappeared and I don't have the warning anymore. Next up, I have action, logics, and blueprint. I see that action, we have almost nothing, and logic, most of them are disabled. So I'm going to fix that as well. See, this is all live. Huh? We are really doing a demo live. So I'm going to list the module. I can see that almost all of them are disabled. So I'm going to enable them. Same for the logics. I'm going to enable them as well. Okay, now finally, you can see now I have all the modules enabled. Okay, so I have my event publish trigger entry point. So what could we do? For example, I could add, I could send a mail whenever an event is about to be published. To do that, I just go into action, search for the send mail module, drag and drop it into the interface. Then I can configure this module. So who will be the recipient of that mail? So I can view all my users, I can select all accounts, I can select all admins, or just keep all admins. Then I can select the subject of my email and the body of my email. So since these can be quite large, you cannot do it in this interface. You have to click on this option button. And I could say, for example, a new event has been published. And the body would be the same. I could even do something cool, like, for example, the event with title event.info has been published. And this will be automatically interpolated with the value of the info field on the event. So it's basically going to be replaced by the title of that event. All right. Another thing that I need to do is to connect the two. So I connect the output of the trigger module to the input of my send mail module. I can save. And now each time an event is about to be published, an email will be sent to all admins. So unfortunately, that was a kind of bad example because if you remember in the settings, emailing was disabled on that instance, so we won't be able to see anything. But what I could do is to show you another example that would affect MISP behavior or even modify data on the fly. All right, so let me get rid of this. And now let's consider another situation. Let's say that I want to prevent any event to be published if they have a specific tag. So I will create a test event for that, test event for workflow. And what I will do is, if an event has the tag Conti, I want my event to never be published. So we'll just create one attribute so that I can publish it. All right, so I have my event ready. If I publish it right now, as expected, the event is going to be published, right? So I'm gonna unpublish it. And now we'll create a workflow that will prevent the publication to happen if we have the Conti tag attached. So how can I do that? Well, I can prevent the publication if I'm using the stop execution module. So this stop execution simply stop the execution of the current process that is taking place. So since I'm going to stop the publishing, the event won't be published. So if I do that, now I will never be able to publish any event, right? Because each time an event is about to be published, I'm going to stop the execution to happen. So let's try to see if it works. Publish, and you can see the event is not published as expected. All right. So now let's add the condition to only prevent the execution if our event is tagged with the Conti tag. For that, I will go in the logic panel and I will use one of the if module, specifically the if tag. So with the if tag, I can configure the logic that I want to apply on for the rest of the execution. So we have an event that is about to be published, and then we check. We want to check for the event. We want to see if it's tagged with any of the tags that will be specified below. So we want to check for Conti. So in this situation, if the event is tagged with Conti, then if the condition is satisfied, we stop the execution. If it's not satisfied, then we continue. If there is nothing, it just simply means that the execution is complete, it's done, there is nothing else to do, and so it's a success. Okay, so let's try. Let's save it like this. And let's try again. So let's try to publish. And you can see the event publication didn't happen because we have the Conti tag attached. Now let's try to remove this tag. And let's try to publish it again. You can see that now it worked. So that was, let's say, a weird example, but it can be useful, for example, if you want to have some kind of automation, like you would have vetted. Actually, a totally valid use case is to use vetted tags for publication, where you would have some junior analyst that would create the data, and then senior analyst that attach a vetted tag, allowing the publication to happen. And when you publish an event, you basically share it with the world. So if you set it up so that only the event that are tagged with the vetted tag can be published, then you achieve this kind of multiple step and publication control. So that was a quick example. The system is really powerful but there are some quirks that are difficult to understand at first, I would say. So for that, we have you can find online on YouTube some pre-recorded session on how to use the system, and we also have some slides that I will share in the chat that extensively describe most of the interesting feature that that you can use using this system. There is just one last that I want to mention is the blueprint one. So right now we don't have any, so I will solve that issue by simply going into the blueprints and updating the blueprint library. So this blueprint library is coming from a repository called MISP Workflow Blueprint that I will bring on screen. So this is a publicly accessible library that has, I don't know, a couple of blueprints. It has 13, mostly about curation. For example, there is one that normalizes TLP and PAP tags. There is one blueprint that remove the automation flag, also called the IDS flag, from non-malicious hashes. One that check in warning list if we have false positive, and if we do have false positive, remove the IDS flags. Another one that checks the validity of URL on by doing queries on Google Safe Browsing or Abuse IPDB. So these are really good examples to add some curation and automation to your data without much implementation or time. It's really fast to do. So how do you use a blueprint? Well, let's go back to our to our workflow. This is our workflow. You go on the blueprint panel. You select one of the blueprints. So let's take a very cool one. This one, for example. This one, as you can see, it has 7 nodes. You drag and drop it. And then it creates this blueprint with the module already configured with a nice frame around it so that it describes what this blueprint tries to do. And you simply connect the trigger to the blueprint entry point. You save it, and that's it. You have, what does it do? You have the removal of automation flag from false positive tripping over warning list enabled on your system. And what's really cool with this blueprint from the curation library is that you can chain them together. For example, if you want to remove automation flag from non-malicious hashes, you create this next blueprint, and you can connect the output of the first blueprint to the input of the second one. So these are really cool examples to see what you can do and how complex the task can be by using the workflow system. You're just simply chaining few modules, and it can do really cool automation out of the box. All right, that was a quick introduction to the workflow. Let's see if I missed any question regarding that specific topic. Could not access workflow system. Yeah, so for that one, you won't be able to access it. You need to have site admin privileges to access the workflow system, similar to the settings and diagnostic, because you can do really nasty stuff if you can overwrite data on the fly. That means you could change the distribution, you can attach or remove tags which can alter the synchronization and ACL in place. So yeah, since you have a lot of control, that can lead also a lot of danger. And obviously we won't expose that to any random users. You have to be a site admin or a super admin of the server to access that system. Yeah. Next one. Do you know what these dependencies are? Yeah, it's described on the slide. The most important one, you need to have the background job enabled. And to be honest, if you're using MISP without background job, I don't know how you can achieve that, because there are so many tasks that happen in the background that I wouldn't even dare trying to run MISP without background job. And aside from that, as long as your workers are healthy and you have enabled the workflow system, that should be it. You don't even need MISP modules to make use of the workflow system, though it's extremely recommended. Oh, someone, Jeroen pasted the documentation. I didn't see. Thank you. All right. If there are no questions about that specific topic, feel free to ask question on anything that we saw today or even before, or any generic question that you might have about MISP. We have a couple of minutes remaining before the end of the session. So now is your time. Feel free to ask them in the chat. And with that, I will just stop the recording. So for those who are watching this recording video, thank you for watching.
Thank you.